Similar to z-test, we have another test called the t-test. In this video, we will talk about the differences between z-test and t-test. Now, z-test is used when the population average is known. So when we know the population average, I'm denoting that by mu, and the population standard deviation is also known to us. So when we know the population average and we know the population standard deviation, and the sample size is greater than 30. This is when we use a z-test. Now it is very unlikely or very rarely you will know the population standard deviation. The population standard deviation is usually unknown to us. So that is why it brings us to t-test. In a t-test, we know the population average. But we do not know the population standard deviation. So this is unknown to us. We have the sample size. So here the sample size can be anything. It can be less than 30 also. And in this case, we know the sample average. We know the sample average and we know the sample standard deviation. So this S is the sample standard deviation. And here we know the sample average. Sample standard deviation is not needed here. Okay. So in both these tests, what we find is we take an observation from a sample and we try to see how far is that observation from the average of the population. So both of them, they measure the same thing. They measure how far is the sample from the average of the population. And accordingly, we either reject our null hypothesis or we fail to reject our null hypothesis. In these cases, we have the null hypothesis as that the sample is the same as the population. It is only due to luck that we got a slightly different result in the sample. And the alternative is that the sample is indeed different than the population. So in both cases we find, so in the z-test we find z value, which is x bar minus mu divided by standard deviation of population root n. So this is how we find the z value in z-test. This represents how far is your sample from the average of the population. So let's say this is the sample. So how far is the sample from the average of the population? And accordingly we select, if we are doing a one-tailed z-test, we calculate this area which represents our p-value, and accordingly we reject or fail to reject our null hypothesis. Now in a t-test is very similar. In a t-test we find the t-value, which is very similar to what we have here. We have x bar minus the average. Now instead of the population standard deviation, we have the sample standard deviation divided by root n. So this represents the t-value. Now this t-value or a t-test does not follow a normal distribution. It follows something called as t-distribution. It follows a t-distribution, also known as student t-distribution. It follows a t-distribution which is very similar to a normal distribution, but it is wider at the edges. So if this is how a normal distribution looks like, the black one will represent a t-distribution. So this is normal distribution and the black one is t-distribution. Now a t-distribution depends upon the degrees of freedom. It depends on a parameter called degrees of freedom. As the degrees of freedom increases, the t-distribution moves closer to a normal distribution. T becomes normal distribution. So for the degrees of freedom to be very high, a t-distribution is similar to a normal distribution. So this is how you calculate the t value, and using the t value you do a hypothesis test, and once again you either reject your null hypothesis or you fail to reject your null hypothesis. So this is the difference between z-test and a t-test. In case of a t-test, the population standard deviation is not known to us and the sample size is usually not 30, it's less than 30. For a z-test to be applicable, you must know the population standard deviation and the sample size must be greater than 30.